All right, here we're asked to determine if this series is convergent or not. Well, let's see maybe a comparable one. On top, what's going to kind of win out is the biggest power here. On bottom, what's going to win out is the n to the fifth, but it is kind of over or under a square root there. So a comparable one on this one looks like maybe the series 2n squared over the square root of n to the fifth power. Well, let's try to simplify that a little bit. The 2 we can pull out. So now we got n squared. Also, if we do square root of n to the fifth power, remember square root's like a power of half. And so that would be similar here to or the same as this. And if we have power to a power, that would be the same as n to the half of 5 would be 2.5 power. So simplifying that one more time, if we have exponents on numerator and denominator, we know we subtract, so that would be the same as n to the 1/2 power. Here, that series would be divergent by p series, because our p here, our exponent, is a half, and that's less than or equal to 1, then it's going to diverge. So what we have to see now is the one we started with, is that bigger or smaller? Well, here it's kind of tough to tell if it's going to be bigger or smaller, because although we are adding something in the numerator which would make it bigger, we're also adding something in the denominator that makes it bigger too. So this would be maybe a good one to just go right to limit comparison. We're going to take the limit as n goes to infinity of the series we're starting with here, 2n squared plus 3n over square root of 5 plus n to the fifth, all over our comparison one, which we said was 2 over n to the half power. Once we had simplified it, that's what it came out to be. So what is this one? What is this limit going to be? Well, let's try to simplify it. So first, let's multiply by reciprocal here. So top and bottom. Okay, so now our limit as we go to infinity is going to be, on bottom we got 2 square root of 5 plus n to the fifth. On top, let's distribute that n to the half. So if we add that to each one, this is going to be 2n. 2 plus a half is going to be either 2.5 or 5 halves. And 1 plus a half is going to be n to the 3 halves power. All right, so next let's multiply or multiply by the biggest one here. So we'll multiply by 1 over n to the 5 halves. On bottom, let's do the same. In the that'd be like multiplying though in the denominator by square root of 1 over n to the fifth. It would be equivalent thing. So that makes our limit here just 2 plus 3 over n. On bottom here we got 2 times the square root, 5 over n to the fifth plus 1. So evaluating that, those two of those are going to go to 0 there, so it's just going to be 2 plus 0. On bottom we got 0 plus 1. Well, square root of 1 is 1. This ends up being 2 over 2, or just 1. So that is a positive finite number. And so this comparison is going to be able to work. So what we can say on this one is our series up here is going to be divergent by limit comparison to p-series. So we would have a divergent one by p-series. All right, let's take a look at one more here. Why don't you pause the video, try this one out, and see what you come up with. All right, let's see how you did here. Our comparable one would be to 1 over 2 to the n, which if we just think about it, we could say this is to the n power 2 because 1 to the n is just still 1, and then we could say it's 1/2 to the n, which is a geometric one that should be convergent because our r value is less than 1. So we'd want to compare it. However, I don't think we can do a straight comparison because if we compare it to this one, we need this one to be less than our convergent one to do direct comparison, but that should be bigger if we are minusing from the denominator. So we can't do direct comparison. We can do limit comparison though, so put the limit series we are looking at and compare it to our comparable one here. Here we can multiply both numerator and denominator by 2n. Then let's multiply by 1 over 2n. And then we have the limit as we go to infinity. Well, that term is going to go to 0. And so we just get 1 over 1, which is 1. That's a finite number. And so what we can say on this one is this is going to be convergent by limit comparison to geometric. And that would be the answer. So hopefully you had come up with something like that.